the problem says the probability that a person has a deadly virus is 5 out of 1,000. Is that likely or unlikely? 5 out of 1,000. Unlikely, right? That's not very likely. A test will correctly diagnose that you have it. So if it's plus and you have it 95% of the time, it will incorrectly diagnose you. You don't have it, it'll say you do have it 20% of the time. Those are pretty good tests for a rare disease, 5 out of 1,000. So what we want to do is set up a nice little tree diagram of what's going on. So here's what you're going to either have happen. You're either going to have the disease or you're not going to have it. Do you agree with that? Okay. Then, if you have it, it's 0.005. If you don't have it, it's what? 0.995. Good. Good. So now we're going to get to the actual test. Now the test can either be positive or negative. Positive or negative. So if you have it and the test is positive, so you have the disease and it's positive, it works 95% of the time. When will it come out negative if you still have it? Huh? What do you think, Fiona? If you have it, 0.95. If you positive, yeah, it'll be 0.05 for that. So then if you don't have it, it's going to come up positive that you have it 20% of the time. So the other one's going to be point what? 0.8. Okay. All right. So when we set this tree diagram up, we're just setting it up so that we can do a nice little multiplication property for a situation like if I have it and the test turns out positive, it'll be this product. Okay, so let's look at what we have here. Find the probability the test given gives you a correct diagnosis. So I'm going to label these A, B, C, D. A, B, C, and D. These are arms, so it's going to be this times this times this, and so on. Which of these arms, A, B, C, and D, will give me a correct diagnosis? Turn to someone you haven't talked to yet. Tell them which arms are going to give you the correct diagnosis. Go. It makes a difference. All right, good. Rebecca, what did you come up with? So you have it and it says you have it would be which arms? A, B, C, D. Which arms would that be? What's that? A, yeah, because you have it and it says you have it, and then there's one more. You don't have it and it says you don't have it. So A and D, right? So the way we're going to use this is this will help us lay this out. We're going to have 0.005 times 0.95. I have it and it's positive, plus 0.995 times 0.8. And there you have the probability that it's correct. It could either be I have it and it's positive, or I don't have it and it's negative. Could someone take your calculator, tell me what that is? 0.8 what? 0.01. Thank you. All right, now that's okay. But here's the crazy part. Are you ready for this? A given test says that the patient does have the disease. What's the probability that you don't have it? Okay, the test says you do, but what are the chances that you don't have it? So I'm going to remove these, and I'm going to see what we can do with which of these arms are we going to be looking at. Given the diagnosis that the patient does have the disease, so is that a plus? Is that a plus or a minus? Plus. That means you have it. So given the test diagnosis, the patient does have it. So you either have it and it turns out positive, or you don't have it and it turns out positive. A and C are the total ways that you'll have a plus, that it will positively test. But one of these, what's the probability the patient does not have it? So which arm is it's plus, but you don't have it, A or C? C. So what you'll do is you're going to do Bayes' theorem, which is the one that you want, 0.995 times 0.2. I don't have it, and it turns out positive, over all the ways that it can turn out positive. Positive have it, and positive don't have it. Are you ready for this? This is a crazy answer. When you multiply this out, what do you get? To call that 0.98. 98% chance that you don't have the disease. So here's what's going on. There's this rare disease that 5 out of 1,000 chance of having it. Everybody look up here. This could change your life someday. I hate to say it, but someone's going to get a test that they're going to have this situation. With this amount of, that's pretty good, 95% and 80%, those are pretty good. But here's what they're saying. If this test is positive, there's a 98% chance you don't have it. How can that be? 98% chance you don't have it. And the reason for that is that this chance of not having it, 99.5 times 0.2, this 95% of 0.05 doesn't do much for you. This is very little. This is going to be almost the same value, 1, isn't it? This is not going to change that denominator very much. This is like 1 times 0.005. That's not going to affect this. So the reason that this is such a skewed falsehood is because you have such a rare disease. So if you have a rare disease and a test comes out positive, what should you do? Second opinion. It could change your life. I'm not saying not to worry. Everybody worries about things, but when you hear news like that. But the math, this is nothing to do with biology. It's nothing to do with anything scientific. It's a math. When you have a very unlikelihood of something happening, and then you're doing some testing and there's a chance of error, this is going to be very likely that you have a false positive. Before we go any further, at the bottom of this sheet or bottom of this slide, would you write a little note? How does this apply to your life? What can you learn from this part B? It's real quick, though. Given that the test diagnoses that the patient doesn't have the disease, what's the probability the patient does have it? So I'm going to write this out. The probability that you does have, knowing the test is positive. Test is negative. Okay? So let's look at all the negative arms. The negative arms will be B and D. So you're going to have 0.005 times 0.05 and 0.995 times 0.8. And then given that the test says you don't have it, it's a negative test. That's the total ways of having a negative test. I could write it, what do I have here, green. These are the total negatives. 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 Okay? And that's what I have down here. What's the probability the patient does have it? Well, the does have is it B or D? Turns up negative, but I do have it. Is that arm B or arm D? B. So then we put at the top 0.005 times 0.05. And then this is an interesting answer. Could you crank that out for me? It's pretty low. It's pretty low. I want to say like 0.15. That doesn't sound right. Point, what's that? 003? 003 or 0.03? So it'd be 0.3%. Okay. Is that, anybody second that? You got it? Okay. So this says, and here's the glitch of this. If you do have the disease, okay, let's see. If you get a positive, there's a 98% chance you don't have the disease if it's rare. If it says you don't have it, okay, then there's a very unlikelihood that you do have it. That's what they're saying. One more time. If you don't, let's say you don't have the disease, thank goodness. Okay, but it comes up positive, there's a 98% chance that it's a false positive. But if you don't have the disease and it comes up negative, there's a 0.003 chance that that's wrong. And so you can trust the negatives, don't trust the positives. Does that make sense? Fun stuff. All right. Good. Just